All right, folks, I did not give you an equation. I gave you what? I gave you points. I gave you a table of values. That's just as good as giving you an equation. Now, normally they would probably tell you in the problem what kind of function it is, and I'm just going to go ahead and tell you this is quadratic. If you didn't know, then you'd have to plot the points. Y'all remember how to plot points? Let's go through this. Okay, so where do I go when I know points? I go to stat. Let me clear out my calculator here. I go to stat, edit. It's already on edit, so I just hit enter. That's where I input all the data that I know. And when you've got a quadratic function, which this one is, you need to enter a bunch of points. Okay, so always double check yourself right here that you got everything in the right position. X is across from Y's like they should be. Now what? Stat calculate. And I am just telling you this is quadratic. 9 times out of 10 the problem tells you what kind of function it is, which is number 5, quadratic. And then a bunch of enter, 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 and it will tell you what A, B, and C are. So now I can write the equation of this parabola, this quadratic function. Y equals negative x squared plus 6x plus 8, right? Where do I go now that I know an equation? Right. Y equals negative x squared, what was it, plus 6x plus 8. Now, what I asked you for was domain and range. On any good old-fashioned random parabola that's not a real-world problem, what's the domain always going to be? All real numbers. That's super easy. Now, again, that's when it's not a real-world problem, when it's not attached to like a rocket taking off or a golf ball being hit. If it's just a random old parabola out there in the world, all real numbers is domain. Range is a little different. You've got to find the vertex. Very good. And you need to know what kind of parabola you're looking at. This is a frown parabola. The domain goes on forever. The x and y, the left and right, the x's, the left and right edges have arrows. Range is top and bottom. Well, on the bottom it goes on forever, but it does have a top. That's the vertex right there. So yes, you need to find the vertex. You can do that half brain, half calculator, where you find the x value, the opposite of b over 2a, and then look at your t-chart to find the y. Sometimes, to me, it's just quicker to do calculate maximum or minimum. In this case, it's a maximum. That's where it asks you for a left and a right boundary. Just make sure your cursor is to the left, and then hit enter. When it asks for a right boundary, you can punch in a number you know is to the right, or just move the cursor till it's to the right. It's going to pop up those arrows. The only thing about the calculator way is the x value isn't very accurate, always. What is the actual x value? 3. And do we even need that? Not for range. Range doesn't care about x's at all. It cares about y's. So what's the very highest this parabola will ever get is 17. And what are all the other y values compared to that? They are all less than or equal to 17. Are we good with that? Finding zeros. I've got to let y equal 0. That's why it's called zeros, roots, x-intercepts. And then I calculate where they intersect. It does have 2 zeros. It has a negative 1 and a positive 1. I'm getting negative 1.123. Negative 1.123. What was the other one? 7.123. The positive one was 7.123. Are we good with that? Now, please, 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 folks, I need you to pay attention because I'm about to change this a little bit. This is where I still have kids who are struggling, especially with domain and range. Now I'm going to attach it to a real-life problem. Most real-life problems happen only in the first quadrant with positive x's and positive y's. Not always, but most of the time. First period was very sick of rocket problems, so they decided this was a football problem. A football player threw a football, nobody caught it, unfortunately, and it landed on the ground. Now, the equation was y equals negative x squared plus 6x plus 8. Can you tell me what height the football was thrown from? 8. Because that's the y-intercept. Remember the y-intercept of the equation we just found? Same equation. I'm converting it into a real-life problem. So the vertex is still at 3, 17. I've got a negative root over here at negative 1.123, and I've got a positive root over here at 7.123. Same question, except now I'm turning it into a real-life problem. That will affect the domain and range. What's the domain now? It's not all real numbers anymore because now I have a real-life problem. 0 is my lowest x value. Domain is about time usually on these kinds of problems. This is before he threw the ball. What's my highest x value? The positive root. Because what's happening after this? It ends. It's on the ground now. That's how long it was in the air. 7.123 seconds. And all of the other x values are somewhere in between. So that's my new domain. Now I have endpoints for the domain. It's not all real numbers anymore because I made it a real life problem. The range also has a top and a bottom now. It always had a top, but now it's also got a bottom. What's the lowest range value? That makes sense. 0. That's when it hits the ground. What's the highest range value? 17, and all the other y's are in between. So there's my new range. Okay, so how long was this thing in the air? 7.123 seconds. How high did it get? 17 feet. How long did it take to get to its maximum height? 3 seconds. What height was it thrown from? 8 feet. Must have been a really tall quarterback there. Okay, now I am going to show you some random parabolas. Just random parabolas out in the world. They're not attached to real life problems at all. Here is a parabola. It's got a vertex, I'm just making this up, of -2, -8. Who can tell me the domain? What is it? All real numbers. That's easy. Domain's always all real numbers when you got arrows on the left and right. What's the range? -8. The highest y value on this whole thing is -8. All the other y values are under it, not in between it, under it. All right, here's a smile with a vertex of +7, -10. What's the domain? All real numbers. What's the range? Y is greater than or equal to -10. All right, I'm going to make up a real life problem. I'm sorry, back to rockets. I know those the most. Let's see. Soccer, no. Basketball's not going to go 105 feet in the air. Okay. What was the rocket's height when it was launched? 8 feet. How high is this rocket going to get? 105 feet in the air. How long is it in the air? 4.125 seconds. How long does it take for it to get to its maximum height? 2 seconds. What's the domain of this thing? No. 0 is less than or equal to x is less than or equal to 4.125. This is when it landed. This is before we started the timer, before we launched the rocket. What's the range? 0 is less than or equal to, y is less than or equal to 105. That's the lowest height is when it hit the ground at 0. It won't let me circle it. And the highest height was 105. Is this 8 going to be involved in the domain and range? Not unless the rocket went straight up and straight back down and never landed on the ground. But that's not what usually is happening here. Some people are using the 8 when they shouldn't be. Okay, so that was your little review. Now, we still have to take our major exam on quadratic functions. We're still going to be doing little bits of review here and there, but we are moving on, finally, to linear functions. Linear functions. We're going to do a whole bunch of real quick review because I found out today in first and second period, not so much third, that they remembered a whole bunch of stuff about linear functions. Miss Wynn did a great job of teaching all about linear functions. They're lines like this. Y equals mx plus b. That means it's a function that doesn't line up in a smile or a frown. It lines up in a straight line. It has a slope and a y-intercept. So the slope is m and the y-intercept is b. Okay, now, This is the form that you probably learned about last year, and we will definitely use this form quite a bit. One way that we're going to extend it, though, there's more than one way to write the equation of a line. Today we're just going to stay focused on this. Slope is in front of x. Y-intercept is the number added or subtracted at the end. So y'all are very familiar with that, right? What we're going to do today mainly is focus on how to find slope if you know 2 points on a line. We're going to get to there. That's our end point. But I want to do a little bit of review with you first. One of the things that I was very glad to find is that my kids could now look at the equation of a line and look at a picture of the line and tell me the equation. And that's a very important skill to have in Algebra 1. Now, don't laugh at my line. I'm going to do my best to connect these dots. I just said don't laugh at my line, and you immediately start laughing. Okay, pretend like that's perfectly going through those nice big dots I made for you. That's close. That's the best answer I've heard so far. Yeah, the slope. Let's first talk about the slope. This is definitely a negative slope. I can tell this is negative because this line is going down. You read a line left to right just like you do a sentence. So if you're moving your eyeballs across the page, this line is going down as I move to the right. So that's a negative slope. Now, slope, remember, is rise over run. In other words, it's the change in the y's over the change in the x's, and that's going to be important when we come to do the math. Okay, so to get from here to here, for example, I would rise down 1. That's why it's negative. And I would run 1, 2, 3. I'm going to go down 1 and over 1, 2, 3. Down 1 and over 1, 2, 3. So my slope is negative 1/3. What's my y-intercept? Positive 2. So I can write the equation. Y equals negative 1/3 x plus 2. Slope's in front of x. Y-intercept is at the end. Okay, also, let's say you wanted to go from this point all the way down to this point at the end. That would work as well. I would have to go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down 4 and over 12, guess what that reduces to? Negative 1/3. So it doesn't matter what point you start at or what point you end at. I do like to move forward across the line. Of course, third period has to be difficult, and I had some kids who wanted to go backwards. Let's talk about how you could go backwards. Like if I wanted to go from here to here, I would go up 1, but then I would have to go backwards 3. Up 1 and backwards 3. So your negative sign would be on the bottom. But overall, that whole slope is still negative. Now, when you make a slope negative, normally they don't leave it on the bottom. Normally they move it to the top, so keep that in mind. All right, I'm going to draw some random lines. I want you to see if you can find the equation. Okay, don't say it out loud. Give everybody a chance to think. Give everybody a chance to think. Give everybody a chance to think. The easiest thing to find for me is usually the y-intercept. So I know I should have an equation with a what at the end of it? A -1 at the end of it. Now, the slope. This line is going up, not down, so it's got a positive slope. I'm going to go from here to here. How do I get from here to here using rise over run? Up 3 over 1. Up 3 over 1. So the equation of this line is y equals 3x minus 1. The y-intercept is negative 1. The y-intercept is negative 1 right here. What do you mean that makes no sense? Yeah, it was. All right, what's this one? Y equals 1/2 x minus 3. The slope is going up 1 over 2, up 1 over 2, up 1 over 2. That's why my slope is 1/2. My y-intercept is negative 3. 3/4. Yes. If it was going up 3 and over 4, you would put 3/4. It would be 20 over 1. All right, what about this? Now that slope is 0. That line has a slope of 0. That's absolutely correct. This is y equals 2. We don't even usually write the x because the slope is 0. And every y value on this line, no matter where I look, is a 2. So this is just y equals 2. And yes, those lines, these flat horizontal lines, always have a slope of 0. And you do need to know that. Because I could write this way. Isn't that still the same thing? But normally, if the slope is 0, we just normally don't even write that whole part. All right, what about this line? This is an outlaw line. This is not a function. It also doesn't start out y equals. Every x value on this line is a 1. That's why the equation of this line is x equals 1. Do you see how it would fail the vertical line test miserably? It's not a function. It doesn't even have a slope. It doesn't follow any of the rules. What is the slope of this thing? Undefined. Okay. Yes, I heard all the stories about Miss Wynn's little tricks. Okay, now, I'm going to show you my little trick, and then we can talk about Miss Wynn's little trick, which everybody seemed to like better. But this is called slope face. Okay, so these lines have negative slopes. These lines have positive slopes. Vertical lines have undefined slopes. Horizontal lines have slopes of 0. It's his dimples or his piercings. I don't know. Okay. Now, here was Miss Wynn's story. A guy is hiking up a mountain, right? Puff, puff, positive. He's going up the hill. Then what was down? Nice, negative, 0 fun, 0 fun, 0 fun. And then he yells undefined as he's falling. Okay, so anyways, whatever helps you guys. You need to know that these kinds of lines have slopes of 0. These kind of lines have undefined slopes. My way is just a face. Okay, these are his eyeballs. This is his nose. And this is his mad, smiley face. There he is. We'll call him Julian. Well, he's going to have piercings one day, right there. Right here. All right. Anyways, let's focus in more. Oh, one other thing before we get off the grids. All right, here is a line that I definitely want you to be familiar with. I'm going to... Yeah, this is y equals x. Okay. Now, that is a very special line. Why do you think it's special? It does go through the origin. That's a fact. It is the parent. It is the mom. This is the parent function for all lines, and you do need to know that. That's the simplest linear function you can draw. It's got a slope of what? 1 and a y-intercept of 0. Now, remember that the value of a, remember how a affected the width of a parabola? It can make it skinny or fat. It can make it open up or down. Y'all remember that? Slope is similar to that. Slope does some things to a line. It controls the steepness or the flatness, and it controls whether it goes up or down. So it's kind of like the value of a, but not quite. So here's y equals x. Now, if I were to ask you, is it steep or flat, you would say it's neutral. It's right through the middle. It's rising 1 and running 1, rising 1 and running 1. So it's got a slope of 1. That's like neutral. It's right perfectly through the middle. Now, as we start changing slope, it's either going to get steeper, which means it's going to rise faster, or flatter, which means it's going to run faster. Okay, how do you think you would make it steeper? What do you mean adding a 1? Tell me how you would change the equation to make it steeper. Change the y-intercept? Okay, the y-intercept does not affect steepness at all. That's not going to make. That's going to change it from a line to back to a parabola. Make it a fraction. Okay, let's try making m a fraction. Let's make it y equals 1/2 x. If you're ever not sure, because this is something they love to ask, how did the function change? They give you one equation and then tell you to change it and ask you what happens to the picture. Here's y equals x, which is our parent. I'm going to compare that to y equals 1/2 x. Somebody said they thought it's going to get steeper. Let's see. There's my parent, y equals x. Here comes y equals 1/2 x. Did it get steeper? No. It got flatter. Kind of like how a fraction value of a makes your parabola wider, a fraction value of a slope makes you flatter. Fractions make you fat and fractions make you flat. Okay, because think about this. You are rising only 1, but you are running 2. My y-intercept is still at 0 with this. Y equals 1/2 x. But I'm going to go up 1, but over 2. Up 1 and over 2. Up 1 and over 2. That's going to make it flatter, folks. This is about where I started losing it with third period. I don't care if you find this fascinating or the most boring thing in the world. You've got to know it. All right, now, if I want to make it steeper, then you need to increase the slope. Make it bigger than 1. If your slope gets smaller than 1, it's going to get flat. If your slope gets bigger than 1, like let's change it to a 3. So we're going to go from y equals x to y equals 3x. My y-intercept is still going to be right at 0, 0. But now instead of going up 1 over 1, up 1 over 1, I'm going to go up 3 and over 1. Up 3 and over 1. And that's going to make it much steeper. Now, what would I do if I just wanted it to change directions? I didn't want to change its steepness. I just want to change its direction. That would be y equals negative x. Y equals negative x just makes it go the opposite direction. So let's please record some of that, okay? Look, you want to look at the slope to tell me if it's steep or flat, and you're going to have to do this on your homework. You want to look at the absolute value of the slope, because the negative sign does not affect the steepness. The negative sign just makes it go down instead of up. So if I want to deal with the steepness of the line, I cannot deal with the sign. I just look at the absolute value. If it equals 1, we call that neutral. If it's something that is bigger than 1, that's when it gets steep. And if it's something that's less than 1, then we call it flat. Okay, so slope will tell us whether it's steep or flat. Now, if we look at the sign, if m is negative, what does that tell us? Then the line is going down. If m is positive, then the line is going up. And I don't know if it's going to be going up steeply or up flatly until I actually look at the value of m. Take the sign off. The sign tells you up or down. Then just look at the value. If it's bigger than 1, it's steep. If it's less than 1, it's going to be flat. If it's exactly 1, then we call that neutral. It's right through the middle. So we talked about what slope does. Slope controls steepness and direction. Y-intercept, like on any function, the y-intercept moves your function up or down. Okay, for example, we always compare things back to the parent. If I had y equals x versus y equals x plus 3, what's the difference between those two functions? The y-intercept went from a 0 to a 3. The whole function moved up 3 spaces. What won't change? The steepness. Here's my y equals x, and if I move that up 3 units, the steepness is not going to be affected. Just the whole line goes up 3 spaces. So y-intercept changes, move something up or down. Slope changes, make it steep or flat. Now, your homework in just a minute, and I'm going to show you how to do the math in a minute, but let's pretend like you've already found the slope and you're just trying to decide what words to write down for Mrs. Heim. I'm going to make you tell me if it's steep or flat. I'm going to make you tell me if it goes up or down. So pretend like you've done some math and you came up with this slope. Definitely goes down. How do you know it's not going up? It's going down because it's negative. Is it steep or flat? Flat. Ignore the sign and just look at 2/3. Is 2/3 bigger than 1 or smaller than 1? It's less than 1. That means it's going to be flat. All right, let's say you had a slope of -6/1. Still going down because it's negative. What else? It is super steep. The negative sign makes it less than 1. That's why you can't look at the negative sign. Just look at the 6. Is 6 less than 1 or bigger than 1? It's bigger. That's going to make it steep. The negative sign doesn't affect the steepness. The negative sign just makes it go down. All right, now, I said fractions make you flat, so some kids thought fractions are always flat. But what if you had 7/2? That's steep. Why? It's an improper fraction, which means it's bigger than 1. Is it going up or down? It's going up. Why do I know it's going up? It's positive. Now, on some of the problems you're going to do, you're going to end up with a 0 on the top, and it doesn't really matter what number you end up with on the bottom. Let's pretend it's a 5. What does that tell you? What is the actual slope? Just 0. That's a special case. If the slope is 0, what does that tell you about the line? It's completely flat, and we use the word horizontal for that. So the slope is actually 0. 0 is a legitimate answer. It's a number. It's perfectly legitimate and legal and fine. And that means you've got a horizontal. Here is what is not legal mathematically. What if you ended up with 7/0 when you're doing your math? It would not be 7. Try to do 7 divided by 0 in your calculator. Do 7 divided by 0 in your calculator. It does not say 0. It says error. Because guess what? You cannot divide by 0. This is when you have that weird situation where the slope is undefined. So you would have to tell me that. The slope is undefined. What kind of lines have undefined slopes? Vertical. This is when the guy falls off the cliff, remember? Okay, dividing by 0 is an undefined operation. You just can't do it. You can divide into 0, but you can't divide by 0. There is a whole little proof I can do for you, but I don't want to waste time doing it now. You just need to memorize. 0 on top is perfectly fine. 0 on bottom, can't happen. Okay, now, how do we find slope if we don't have a picture and all we have is points? Do y'all remember this little formula? I'm going to give you 2 points on a line, and your job is to find the slope, and then you're going to write a description of that line based on the slope, whether it's up or down, steep or flat. Okay, so here is my formula. Why do I have these little subscripts? It's 2 different y values. We couldn't just put y minus y over x minus x, because what would that be? 0 over 0. The subscripts are to tell you this is 2 different y values on top and 2 different x values on bottom. The thing kids mess up on all the time is putting the x's on top instead of the y's. The y's have to go on top. The other mistake I see is messing up in the order. Okay, so let's just do an example. Your homework's going to look like this. They're going to give you 2 points. Like point P is at -9, -2. And point Q is at 4, +2. And our job is to find the slope, and then what I'm asking you to also do is tell me up or down, steep or flat. Now, slope always involves the change in the y's over the change in the x's. You got to subtract the y's on top, subtract the x's on bottom. So I could do this 2 different ways. I could do -2 minus 2. Do you see how I'm starting with this y value? And I'm subtracting this y value. That has to go on top. Then on the bottom, I must go back to this x value, and I must do -9 minus 4. The other way I could have done this is I could have done it backwards. I could have done 2 minus -2, so I could have started with this y value, but that means on the bottom I would have to do 4 minus -9. It doesn't matter which way you do it. But you got to stay consistent. If you're going to start with this y, then you must start with this x. And the y's are always on top. The x's are always on bottom. Let me show you how you're going to get the same answer. What's -2 minus 2? -4. What's -9 minus 4? And a negative over a negative is really positive. So the slope of this line is positive 4/13. Let's do it this way. What's 2 minus -2? 4. What's 4 minus -9? 13. I still get positive 4/13. Because a negative over a negative really means positive. So my point is the order doesn't matter, but you got to stay consistent. So your job would be to do the subtraction and actually find the slope, and if it's reducible, reduce it. That's part of my answer. Now, you also have to tell me up or down, steep or flat. Up. Why is this line going up? Because it's positive. Is it steep or flat? It's flat. Why is it flat? Because it's a fraction that's less than 1. Think about it. If you start somewhere and then go up 4 but run 13, that's going to make you flat. If you're running more than you're rising, you're going to be flat. If your number is less than 1, you are going to be on the flat side. All right, try this one, please. 7, 2, and 7, negative 5. You will have some like this as well. Your job is to mathematically find the slope and then describe the line to me. I would end up with 7 over 0. Please do not write 7 over 0 as the slope. What's the slope? Undefined. That's what I want to see. What does that mean about this line? It is vertical. It's as steep as it gets. It's only rising. It's not running. So I would expect to see these two things right here. Yes. All right, what about this? 4, negative 3, negative 7, negative 3. I'm getting 0 over 11, or you might get 0 over negative 11, but the whole slope is what? The slope is 0. It's undefined when the 0's on the bottom. If the 0's on the top, then the slope is just 0. No, it's not undefined. What kind of line is this? This is horizontal. It is y on top of x. Negative 3 minus negative 3 is my y's. That's 0. And then I did the x's on the bottom. All right, try this one, please. Positive 3, negative 13, 4, 1. Find the slope, describe the line. This one is not vertical or horizontal. I got 14 for my slope. Okay, so that's part of my answer. The actual numerical value of the slope is 14. Is this going up or down? Why is it going up? Because it's positive. Is it steep or flat? It's steep. Why is it steep? Because it's bigger than 1. It's really steep. That's what I expect to see on your homework. The actual slope that you figured out mathematically, and then most of them are two-word descriptions. The only ones that won't have 2 words are the ones that are completely horizontal or completely vertical. Then you could just write horizontal or vertical. All right, you need to get started on your homework. It's 2 different sections, so please look at your page and make sure you know what I'm talking about. It's page 304 and 307. 304 is kind of at the top. 307 starts in the middle. You're going to do 1 through 6 on both of those sections. Please don't listen to the directions. Listen to what I'm telling you. You've got to find the slope, and then you've got to describe it with either steep or flat, up or down. So most of these will have 3 things: the actual slope value, and then either the word steep or flat, and either the word up or down. The only exceptions will be when you get a slope of 0, you would just tell me, oh, that means it's completely horizontal. Or if you get a slope that's undefined, you would just tell me one word, which is completely vertical. Undefined is vertical, 0 is horizontal. Otherwise, it's going to have 2 words, up or down, steep or flat. And you can get started now.